marks in the same circuit will be doing the operation. So in theory we study it separately, but in practical the same circuit performs the marks operation as well as the D1 marks operation, right? So multiplexer means many to one. So it has many inputs and a single output. So mux is also known as many to one, and it's also known as data selector. So from n number of inputs, we select any one of the input. So it's also known as data selector. Then we use multiplexer in analog and digital circuits. So analog circuits we use in the form of base and transistor. So in digital circuits we will using in the form of gates. Then this multiplexer is used in transistor side for communication purpose. Right? So D multiplexer opposite to this. One to many should be having one input and n number of outputs. Then D multiplexer is also known as data distributor. Then they are used in receiver side in communication systems. Right? So this is the multiplexer. So here we are having n number of inputs. Right? So these are all the input lines. So n number of inputs. Then we have a selection line and a single output. The selection lines are used to select any one of the input from the given inputs. So the function of the selection line or selection variable is to select the inputs. Then it will give the inputs to the output side. Right? So for example, when S is equal to 0 and S1 is equal to 0, the selection line will select the input I0. So this input I0 will be given at the output side. Then, so this is the representation of a mux where I0 and I1 will be the inputs and Y will be the output, and this will be the selection line. So this is the representation of a mux, 2 cross 1 mux. So 2 cross 1 mux consists of 2 inputs and a single output. Right? Then, so different types of multiplexer. 2 cross 1 mux, 4 cross 1, 8 cross 1, 16 cross 1 and 32 cross 1, right? So in 2 cross 1 we will be having 2 inputs and single output. So whatever may be the type, we will be having n number of inputs and a single output. So many to 1, we will always be having a single output in the mux, right? Then, so the number of selection lines is given by the formula n is equal to log 2 to the base, sorry log 2 n. So n will be the number of input and m will be the number of select lines. So depending upon this, we will be selecting the number of select lines. For a 2 cross 1 mux, we will be having a single selection line, right? Then for a 4 cross 1 mux, we will be having a 2 selection line, right? So let's see the types one by one. So first we put the heading as 2 cross 1 mux. When enable is 0, the output will be 0. Then get the output as I naught. See, when NA is 1 and S is of 0, you will be getting I naught. Then when NA is 1 and S is equal to 1, you will be getting I1, right? So what are the possible combinations for S bar? 0 and 1, right? So when NA is 1 and S is equal to 0, you will be getting this as out, I naught. So the selection line will select the I naught input. Then when S is equal to 1, when S is equal to 1 and NA is equal to 1, the selection line will select the I1 input, right? Then the output can be, Y can be written as the Y can be written as Y can be written as E into S bar into I naught plus E into S into I1, right? So E into S bar into I naught plus E into S into I1, right? Then you have to draw the logic diagram for this. log 2 the selection line will select the I not input as output. Then when S is equal to 0 and S1, sorry, when S1 is equal to 0 and S1 is equal to 1, select the I1 input. Then when S1 is equal to 1 and S0 is equal to 0, select the I2. Similarly I2, right? These are all the operation of the 4 cross 1 mask. Then the output y is given by, so S1 bar S0, so input I0 into E. Right, we are giving enable signal E plus then S1 bar S0 into I1 into E. Then S1 S0 S0 bar I2 into E plus S1 S0 I2 into E. Right? Then using this equation you have to draw the logic diagram for a 4 cross 1 mask. What is required? Here you have two select lines, right? So S0, S1. So S0 and S1. We have an inverter also. Right? So first S1 bar, S0 bar, I0 E, right? So you are first S1 bar, then S0 bar, then I0 into E. So we will be giving this to AND gate, right? So this is S1 selection line and this is S1 selection line, right? So here we are having S1 bar. So if you connect it from that line S1 bar, then S0 bar, then input I0 and enable E, right? The next one, S1 bar, S0, I1 and E. So S1 bar, S1 bar, S0, S0, I1, E. So enable, right? So next one, S1, S0 bar, I2 into enable, right? Then last one, S1, S1, S0, I3 and enable. So this is the enable line E. Then we will be connecting all the AND gates to the OR gate, right? So by AND, all these will be getting the output y. Right? Any doubts? For each term, we have to construct a different AND gates, sorry, same AND gates. Then we have to add all these using OR gate. So this is the logic diagram for a 4 cross 1 mask. So logic diagram for a 4 cross 1 mask. Any doubts? Write it down. So for 8:1 mass, we'll be having how many inputs? 8 inputs and single output, right? The Then for 16 is to 1, 16 input and 1 output. For 32 is to 1 marks, we have a 32 input and single output, right? This is the 8 is to 1 marks. Here we will be having 8 inputs, right? So I0, I1, I2, I3, I4, I5, I6 and I7. So how many selection lines is required? How many selection lines? So n value. So substitute n value. So this is the correct answer. So if you get m is equal to 3. So the number of selection line required for a cross must be 3. So the selection line will be S0, S1, S2. Then here we have enable signal. So this is the A cross 1 marks. So next is the truth table. Copy this. This is the 8 cross 1 marks. Then we have 8 inputs, right? And 3 selection lines. So, construct the truth table. We have 8 inputs and 3 selection lines. S0, S1 and S2, right? So, when enable is 1, the circuit operates. Then, what are possible combinations for S0, S1 and S2? 0, 0, 0, 0, 0, 1. These are all the possible combinations, right? So, listen. When S0 equals to 0, S1 equals to 0 and S2 equals to 0, the selection line or the selector variable will select the I0 as output, right? Then when S0 is equal to 1 and S1 is equal to 0 and S2 is equal to 0, the selection variable or selector line will select the I1 input. Similarly, the operation goes on, right? Then the output y is given by for I0, writing S0 bar, S1 bar, S2 bar into I0, right? So you can add E also. Then for I1, S0, S1 bar, S2 bar. So you can write as bar, right? So for I1 into S0, S1 bar, S2 bar into E, right? Then for I3, for I2, S0 bar, S1, S2 bar, right? So I2 into S0 bar, S1 and S2 bar into E, right? So similarly, we have to write for I3, I4, I5, I6, I7, right? Then using this, you have to draw the logic diagram. So same as that of 4 cross 1 mark. Here you have to use 3 selection line, right? So use 3 selection line S0, S1, S2 and draw the logic diagram for 8 cross 1 marks, right? For I3, S0, S1 and S2 bar, right? S0, S1 and S2 bar and 3. So write out for I7 and using this, draw the logic diagram. do it as a homework. So completed. Write it fast. So do it as a homework. So draw the logic diagram for a 8 cross 1 marks as well as 50 cross 1 marks. Completed. Girls are completed. Boys are completed or not? The heading is application of multiplexer. Listen here. So these are the applications of a multiplexer. They are used as a data structure since it selects any one binary input from the n number of inputs. Then they are used to implement the complex logic circuit. Then they are used to time and frequency multiplexer system. Then they are used to other prediction converter. Normally by using multiplexer we can reduce the more number of wires. So instead of implementing more number of logic circuit, we can use a single mux. So these are the application of the multiplexer. So next class we will see about the T-mux.